Good morning. Welcome to the All for One Poland webinar. Today's topic is Beyond the Hype, exploring SAP AI functionalities and real-world implementations. I'm pleased to introduce our expert, Wojciech Lewandowski, and my name is
Hello.
Octavia Radzia, and I will be moderating today's meeting.
My name is Wojciech Lewandowski, and I work at All for One Poland in business development area as integration developer and BTP architect, with recently much more focus on AI topics.
And during today's session, we will be focusing on three main areas: AI-related technologies and components in the SAP landscape, AI implementation scenarios on SAP BTP, and real use case. The webinar will last for 60 minutes. You are invited to ask the questions. You can do it using the questions window on the top of the GoToWebinar tool. And today's session is recorded and it will be available on our website and on our YouTube channel. Right, let's move on to the presentation. I'm giving the floor to Wojtek very soon.
Okay, thank you, Octavia. So I will share my screen. Give me a few seconds. And before we jump into main part of the presentation, I would like you to think how often you hear about AI, in what context, what words or terms are used there, because I hear about it quite often, mostly in a way of its potential possibilities, future aspects, especially how it will take our jobs. For example, headings like this are probably not new to you, or other articles about how AI will change our world and how it will impact our future. I'm not saying that they are not true, obviously, but I think like we are at the edge where the biggest hype after release of ChatGPT in 2022 is slowly dropping, and we can start to realize and explore of the reality of AI usage in business and try to find its potential, how to actually resolve our problem. As a curiosity, I'd like to show you how powerful can current version of ChatGPT can be. Let's look at that example. And as you can see, it is not able to count how many R's are in strawberry word. And obviously, it is cherry picking here, and it is recently known example. So I wasn't the one who discovered it, and I also didn't do any pre-engineering with ChatGPT to force that answer. It was just starting a new conversation and first question in a new conversation. But I wanted to show a bit different perspective at the beginning, that AI also has some limitation at some aspects. We can be still smarter than even the most powerful AI models. And one more introduction slide. I would like you to better understand AI in general, because AI and also generative AI here have become such a buzzword that the real meaning, more of a technical perspective meaning as well, has been overshadowed by tons of some materials, video articles promoting selling or some other marketing stuff related with AI. And if we look at the AI in general, you can see here on that picture that I added a week in a parenthesis. I did it because to make a differentiation between AI, we have to say about weak AI, or in other words, narrow AI, and strong AI. Strong AI is purely theoretical concept for now. Maybe in a few years it will change. But we call all AI that we currently have a weak one, which is why we skip that, because it is just meant by default. And because all AI models are tailored to specific domain. So they are absolutely the best, but in one area, in one field or group of activities related to that area. For example, playing chess. If we look at some chess engine, they are unbeatable by any human, but they are the best only in playing chess. The same model that is unbeatable by any human cannot make even a simple conversation. Then we would need to make a separate model for conversation, for example, large language model. And then if we place here our generative AI, I bet that it might be a bit surprised that it is just a one type next to discriminative AI. So these are complementary type that where both are used in business and both are used in real world scenario, because generative AI is a model of AI that creates new data based on data that it has been trained on. So for example, we have large language model which can generate a new text because this large language model was trained on a lot of other text. And discriminative AI is a AI model that can make some categorization. It can group our data set into some classes to draw some boundaries between this data and so on. For example, we could use discriminative AI model to filter out spam on our email box, just to find out which emails are, for example, business related and which one are a spam or even maybe some fraud attempt and so on. So as you see, both models have a real use cases. And the reason behind generative AI is some so popular term, especially in SAP world recently. I think it's because it is a more effective one to show in a use case. It's always better to see how something is generated. And also, I think that because it just sounds better, because who would want to use a powerful AI model which is a discriminative type, right? And to be mathematically correct, the difference between them is based on model probability, but for our purposes, we can just remember that the difference is based on functional aspects. And then there are a few more very popular terms, and these are machine learning, deep learning, and neural networks. I choose the most common one, in my opinion, even appearing in non-technical articles and so on. And if we try to make a difference between these generative AI and discriminative AI and these other terms, then from technical perspective, machine learning, deep learning, and neural networks are just techniques. So in other words, they are algorithmic approaches to implement one of those models. So we can have generative AI that was implemented using some deep learning technique, as well as discriminative AI model implemented using exactly, I mean, not exactly from coding point of view, but also a deep learning technique to implement that. Okay, so that was a brief introduction, just to have a general understanding and awareness of how we can somehow categorize these very popular terms that we've seen. Okay, and about the presentation, I think we can divide it into two parts. First one is more from a general to specific point of view. So I will start with describing general SAP architecture. I mean a general AI architecture in SAP. Then we go to business technology platform, which is tool for that AI architecture, inside that AI architecture. And also generative AI hub, which is tool inside business technology platform. And then we will see some use case powered by AI. So firstly, I would like to show you how SAP describes its AI landscape, how SAP perceives its own AI landscapes. And then I will try to explain a bit what stands behind that, and also propose my own categorization of SAP landscape to maybe make it a little bit easier to understand. If we look into SAP aspects, it distinguishes three AI categories. First one is Joule, Then embedded AI and AI foundation, we can just refer to this as BTP in general. I will elaborate more about each of these terms later in this presentation. But for now, let's see some SAP graphic that presents these three layers. So we can see that we have Joule, embedded AI, and business technology platforms. But also we can see that at the top, there are three words. And for me, for a while, that was kind of a mystery why they are put there. So I mean relevant, reliable, and responsible. And what SAP meant by them is that it shows you how much SAP is taken care of in aspects of AI solutions. So relevant means that it is tailored to real world business needs. So some problems that are addressed, SAP already provided solution, and every aspect of providing this solution is covered by SAP. So basically, you can just take it and use it. This is what SAP mean by this first word. The second one, reliable, it is morely like AI infrastructure and hardware related. So basically, in every cloud, it is very important to have no downtimes, to be able to scale that, and also to have quality control, availability, and so on. And the last one, responsible, is more ethic related, or some privacy, or some problems related to training of models and so on, because there are many different restrictions in that, not only from ethical point of view, but also from legal point of view and so on. And all of these aspects are taken care by SAP. So maybe it's not so clear at the beginning, because they are just three very general words here. But I would like to ask you to remember these three words, or at least like a 3R rule, because I will go back to this 3R later in this presentation to show you one more thing related with that. The other perspective that you can probably see in many articles related with SAP, or some videos, or other promoting stuff, is like a 360-degree business AI. So that means that the AI is taken care of every aspect of your business. So AI will support every module, every potential area of the business, and so on. And what I see here in general in SAP propositions of this AI architecture is that they are very abstract, at least to me, and they are on a very general, high level, they are on a very high level perspective. And I would like to propose a bit different view on AI across SAP landscape. If we imagine that absolutely every AI related aspect is put inside this box, then we can divide it into not 3, but 4 categories, I would say. First one, the biggest one, is business technology platform. And here I briefly mentioned that it needs to have Cloud Foundry or Kyma runtime environment, because in the previous version of business technology platform, there was also Neo environment, which is already deprecated and does not support all of AI solutions. So these two runtimes are very important. So first subcategory inside BTP is embedded AI. It is actually the same as SAP. But what is embedded AI? Basically, from a user perspective, we can just treat it as a new, nice working, maybe, function. It is just new capability added to some service, not AI related. So as an example, we can take Integration Suite, which is a tool for cloud integration, and it is not AI related, and it has embedded capability called Integration Advisor, which is powered by some machine learning model. But from a user perspective, it doesn't matter whether it's powered by AI or not, because the important part is how it works. It gives us some proposition of data mappings between structure, for example. And basically that's it, because all embedded AI are managed by SAP, are trained by SAP, and are maintained by SAP, by SAP, I mean. And because of that, we basically don't have much more to say about this type of AI. They are just ready to use as a nice function inside some product. And then we have AI business services. And these services are strictly AI related because all of its function based on AI. So it's not like with embedded AI that we have just a few functions powered by AI as something, some additional function, but here whole functionality based on this AI, but also SAP takes care of all of the maintenance aspects and all of the management aspects of this AI behind those services. For example, document information extraction is a BTP service that allows to retrieve information from delivered documents. So it uses some optic recognition techniques from documents. We can have, for example, a picture of an invoice or a lot of pictures of invoices, and we can upload this invoice picture into document information extraction service, and then document information extraction service will obviously extract all of the information from our picture and put it to the target system. Of course, meanwhile, in this process, we have the possibility to manually verify whether it is correct or not. But this is an example of how AI can speed up process of some document management, for example, or replace us with rewriting some data from documents like real paper documents to the system. And the last subcategory inside Business Technology Platform is so-called Generative AI Hub. About a Generative AI Hub, I will talk more in the separate topic during this presentation. But for now, let's see that inside Generative AI Hub, we have AI Launchpad, which is application on BTP, and AI Core, which is an instance on BTP. And this category, this subcategory, is strictly related with development process of AIs or making APIs available for consumption and so on. And here we have two types of models, because this is a place where we can actually have some impact on models, to choose models, also to develop our custom models. So we have option to either take SAP provided model that is already pre-trained and ready to use, or create our own, and thanks to AI core capabilities, train this model, test it, and make it available. Of course, the second option is much more difficult and time consuming. And that is why I would always prefer to, if it's possible, use already delivered models, because these models are also created thanks to cooperation with some AI partners by SAP. It is not our concern what partners or whether there are some license problem or some contracts or something like that, because SAP takes care of every communication between the partners. So we can just have open AI model that is running on AI core, inside AI core, and pretty much that's it from our user perspective. So SAP took care about all discussion with some external vendors about a condition under which they are making their models available to us. And then the second category is, of course, our core of the business, so ERP system. And here we have also embedded AI functions. They work exactly the same as I described during BTP introduction here in this embedded AI capability. And basically it is just a function powered by AI, and we don't have much to say about it. We can just use it, and that's it. Then we have our cloud system with embedded AI as well, working exactly the same. For example, success factors can have some nice function that is using some AI model to give us some data or something like that. And obviously, between cloud systems or ERP systems, we can make connection with each other and also with business technology platforms. So this would be the way to use those developed models by ourselves or those AI partners models directly inside one of these systems, for example. So we can make some communication interface, and as you see, the BTP is this AI most important part in this landscape. And the last but not least, we can say Joule in the SAP AI crown. The Joule, which is a virtual assistant that will help us with many daily based tasks like generating some reports, answering our question regarding to the system, or even performing some task that we describe. But I think not many of you have had the possibility to use Joule. And this is because it is not widely available yet. I know that it can be available, for example, in SuccessFactors instance, but it is not that easy to already leverage Joule capabilities. So it is more like a to-be future concept of this virtual assistant to be integrated with almost every SAP product. So it will be inside our S4 SuccessFactors or even inside business technology platform and particular services there, like inside Analytics Cloud, which is just one of many services in BTP. But we will have to wait a bit more months, I guess, to fully be able to test this Joule in every SAP product, because it's still more of a concept currently. Okay, and now we will go a bit deeper inside business technology platform, because as I mentioned, this is the place where the most important AI related aspects takes place. But before that, I would like you to take a short survey about your BTP usage in your company.
I invite you to vote. Do you use the BTP platform in your company? Yes or no? All right. Thank you very much for all the votes. I'm closing the poll and we will see the results very soon. Wojtek, can you see the results?
Yes. Okay. So I now will switch for a while. Okay, I see. So okay, most of you, great majority of you, have not yet used BTP. Okay, so let's go back to the presentation. So from AI perspective, AI services and other AI aspects are on BTP, and this is why SAP describes BTP as AI leading platform. And I agree with that. But for those of you who have never used BTP, I have to very strongly highlight that BTP is not only AI related. Of course, we are focusing only about AI aspects inside that BTP and general SAP architecture, but inside BTP, we can also do a lot of more tasks. So we can have some application development using some tools that are delivered thanks to business technology platform. We can make some automations, for example, RPAs and so on. integration. That is the example that I've used to show you some embedded AI capability. Data and analytics. I think maybe some of you have heard about DataSphere or Analytics Cloud. They are all available thanks to BTP. And obviously, artificial intelligence. And this is only one of these big 5 areas of business technology platform. So it is much more than just an AI. Okay, so one more time, let's look a bit on SAP perspective of how BTP is perceived by SAP. And we can see that Cloud ERP is in the center, is like a core around and surrounded by every business processes. But business technology platform is a ground for that core, and it is very important because when we think about cloud solutions inside SAP ecosystem, so for example, if our first step is to migrate from S4 to, to migrate from ECC, so from on-premise solution to S4 or other cloud systems, then our second step should be to at least consider business technology platform, because SAP is starting to give business technology platform bigger role. A lot of new capabilities, a lot of new releases of some functions are made available through business technology platform. So it has become like many aspects are more like a side by side, not embedded into our core ERP system. So I would even say that we have our cloud ERP in the center, but BTP should also be considered like a ubiquitous solution surrounding every aspect from application development through automation and integration to AI. But of course, we will be focusing on AI in this presentation. And inside this AI are a few more tools that I would like to show you. I already briefly mentioned them because it is a generative AI hub with some two tools in general that are powered, that are maybe made available thanks to BTP. And these are AI Launchpad and AI Core. And generative AI hub, it's quite interesting because basically there is no such tool, application, or instance on BTP. So to access generative AI hub, we have to launch our AI Launchpad application. And here is the starting view of SAP AI Launchpad, of course, after very basic configuration to make it working. And here we can see in the first section, this in a purple square, we have a generative AI hub. And I think it is the only place where we actually have this name, generative AI hub. So I would even say that it is more of a concept that a set of tools should work combined to achieve the most efficient business aspects related to AI. Of course, in this AI serving model. And generative AI hub itself works a bit like a ChatGPT. So it is large language model that we can chat with. We can make some prompt engineering. We can play with some parameters, which we don't have this option on other widely available large language models. For example, we can decide how predictive answers of our model can be. So it is so-called temperature parameter. So it makes a model a bit more or less deterministic, and a few other options. And we have one more tool, AI Core, which is here in a green section. And AI Core is an instance inside BTP that is related with MLOps. MLOps, which stands for machine learning operations, is a similar to DevOps process. And DevOps process is a process that makes software development smooth. So we can build the whole like a CI/CD pipeline and have every aspect of testing, adding new features, very smooth and taken care without any downtowns and so on. And the same is with machine learning operation, but in AI aspects. So process of gathering data, cleansing data, training our model, then testing it, making some parameterization and so on, is supported by this AI core tool. And I just would like you to look inside this AI core inside machine learning operation, and I will show you only one option here. And if we see inside this AI core, we have a lot of options for developers, but we have also one option, which is deployment here, where we are making our models available on the internet, basically. So everyone who will have a proper credential can make a request to our model. And this model, as I mentioned, can be developed by us. So we can make our custom AI model, which is not that easy task, by the way. But also, we can make it extremely easy and use one of delivered model. So we can have, for example, GPT-4 model running on our BTP platform inside SAP ecosystem. So basically, you can create our chatbot within, I mean, the background of our chatbots within even a few minutes. But as we know, GTP model is owned by OpenAI company. But again, we don't need to take care about that because that is SAP responsibility. And I ask you to remember about these 3 R's at the beginning of this presentation. And it is not the point where I want to elaborate more about them, but there were one more term that was used there, and it was AI Foundation. And at that point, I said that just refer to this AI Foundation as BTP. It was just for simplicity. And now let's see what AI Foundation is. And basically, you are currently looking at this. So it is just a set of models available. It is also a generative AI hub. It is also part of generative AI hub. So as I mentioned, generative AI hub, AI Foundation, AI Launchpad, AI Core, and other AI capabilities should be combined together. And this is, by SAP, the best approaches to leverage potential of these AI solutions. As you can see, most of these models are not built by SAP. Only ABAP code models are built by SAP, but a lot of models are, for example, OpenAI or AWS and other vendors. And now let's go into our use case. But before we will see the actual application, I'd like to say a few words of introduction. And for that, we need to firstly explain what our demo application is about. And it is about supporting ticket operator. So application is for someone who's receiving a lot of internal or external tickets. Some is working in some, for example, IT support team, and it needs to somehow take care of user problems and find a solution and response to that tickets. And to build such an application, we also have to answer 3 questions to understand it. First one, what is RAG type of application? RAG stands for Retrieval Augmented Generation. You don't need to remember that name. But basically, this is just a type of system that retrieves information from delivered documentation and generate answer based on that documentation delivered. So it is like an expert into our product that we have created documentation for. Second question is, how does it know the answer? The most important question, basically. And our system uses so-called embeddings, which are vectors. In other words, even we can say numbers that contains information from our text, so from our documentation delivered. I will explain on some example how these embeddings work in a few seconds. But also let's find out what models are used. And for that, in a standard approach, we can use two models. One for creating those vectors, so-called embeddings, because embedding is just a type of a vector. And large language model to help dealing with natural language. And now let's see a bit more about these embeddings. So imagine we have our objects that contain some information. They don't need to be text. This can be even a picture of some diagram and so on. And we have like a black box with our model inside. And somehow this model generates some numbers from those objects. And when we have some numbers, we can put it into coordinate system. And what happens if we do that? It occurs that when we put those generated numbers in coordinate system, closely related terms or words or even sentences or paragraphs will be close to each other. So the distance between them will be very, very short. And that means that they have similar meaning. For example, if we have Spain and we calculate a vector from Spain, we'll get some vector. We put this in our coordinate system, and we do the same with Madrid. And Madrid is of course capital of Spain, so they are closely related words, and they will be also very close in our coordinate system. And this is all thanks to this embedding model. How it works internally, actually it's not that important, at least not if you are developers, because we can leverage delivered model by AI partners managed by SAP. Okay, and now if the building of such an application, can we divide it into two phases? First one is preparation of our data. So we need to prepare our knowledge base that will serve as an information source for our application to be able to answer our questions regarding that topic. We can do it, of course, giving some documentation. For example, user can put it, or maybe some other application can put it into data storage. And then we are retrieving this from data storage and doing so-called semantic chunking. It is a process of cutting documentation into pieces and to have these pieces ready to calculate these vectors from. But we need to do it in a way that the semantic meaning inside is contained inside one piece. So we cannot, for example, cut a sentence in half and put one part of the sentence inside one piece and the second part of the sentence into other piece, because that would also mean that our information that is contained in that sentence is split in half. And this is not a good approach. Then our application would not be working effective and, of course, efficient. So this is not that easy process, actually, but when we do have our semantic chunking performed, we have a lot of pieces of documentation, so in other words, chunks. We can do some post-validation. We can make sure that this particular chunk contains all the necessary information from this document that it has been retrieved, and also modify it, but it is also more like a validation process. So making sure that the quality of our application is better. For that, we can also leverage some large language model. And then we are going to the second part, where we will use this embedding model, so-called embedder here. So when we have our chunks, so pieces of documents, we are calculating vectors, so these embeddings that can be put in this coordinate system, as an example. And I mean by we, I mean our model is calculating these vectors and put it to the database. But also, when we work with vectors and we need to compare those vectors, not any database would be efficient, because in HANA Cloud, there is built-in vector engine that gives us support in comparing those vectors. So we have ready-made function by SAP to see how close these vectors are to each other. So basically, if they contain a similar semantic meaning. And the second part is more from a user perspective. So basically, user is asking some question. Then we need to, at that point, answer one more question. How does application, our system, knows what the user is asking about? And it knows it because we are also calculating vector from that question. So as you remember, those vectors or embeddings contain information that can be understood by a computer. And if we calculate embedding from our question, we'll know what the question is about, and then we can compare it with our vectors in databases. And the vectors that are the closest one probably contains answer to our question. So we are retrieving those vectors from our HANA database. Then we are leveraging large language model to help us build a response, and we are returning this response to the user. And this is our demo application. And now let's see how it works. Okay, so as you can see, our application is divided into three options. We have ask question, add new ticket, because it is just a demo application, so we need to simulate our tickets that are imported to our system, and a ticket with answers, so some history ticket list with other tickets, like a ticket database. So let's start with the most basic function, and it is asking a question. I will ask about our internal product, which is developed by us. It is called One API, and it is related with e-invoicing system in Poland called KSEF. And I'm asking because there is no widely available documentation and information on the internet about our product. So we needed to provide our own documentation for that system to make it able to answer our question. As you can see, we have some explanation what it is based on our documentation. But also I will ask about myself. And this is interesting part actually, because some of you may think about, that looks very similar like our chatbots that we played with on the internet, for example, ChatGPT. And maybe it's a bit like looks the same, but it has absolutely different functions, because it does not based on the information widely available. So we do not train our model on some database on the internet, so some whatever what is available publicly, and this is why it knows only the answer for questions that we provided documentation. If we would ask about someone who has the same surname as me to the ChatGPT or other models on the internet, we would receive an answer that probably related to someone who's famous. But in that case, I will receive answer about actually myself. As you can see, it takes a few seconds because it's calculating those vectors that I've just explained. And you can see that it knows me because I am author of one of these documents provided. And let's ask one more question to make sure that it's working correctly, actually. So about what is color of the fresh grass? And if it's working correctly, it should not give us an answer, because we don't not contain information about any related topic in our documentation, and that is correct. So let's add some example. Let's add some tickets to simulate our process with ticket related actions for our ticket operator. We'll ask also about our product. So it's our product related ticket. And then we go to our ticket list. It's already analyzing the answer. So the ticket was successfully analyzed. So it provides already proposition of an answer. If we see our ticket here, we already have generated response. And this response based on our delivered documentation. So our knowledge base to that system. Of course, it has some obvious option like status change and so on, like every ticketing system. But also it has one more option, very interesting, which is linked to the document. It will redirect us to the document storage. It is document management service, which is, by the way, a BTP service. And inside that, we could see that we have what document it's based on. Also, we can see a similar tickets here. So the tickets that are, wait, let me make a pause here, because now we can understand that it's not a magic here. It is just calculating vectors from our question and compare it to other vectors from other questions from a history. And now we can see here on the right that we have similarity to other tickets, because at least from my experience, the ticketing system and the operator very often receives the same problems, the same tickets that, and they probably have been already answered like a few months ago or something like that. So that is quite a nice feature to be able to automatically filter what tickets are very similar, or maybe they just contain partially answer to our question if we don't like our generated one. So the operator can do manually almost every task to make it more accurate. And of course, we can edit our generated answer. So and then confirm it, and that pretty much it. So how this application work more from a SAP technologies perspective? Let's see the architecture of that solution. And before we go to an architecture, I just want to mention that the only requirements was to have properly configured BTP, because the whole solution and every technology used to build that solution is running on BTP. Okay, and here we have some diagram with look at the architecture. We can start from the obvious part. So on the left, we can see our graphic user interface on the front end, built with build apps, which is no-code, low-code tool for application development, for front-end Fiori application development. We've used a document management service, which is like a data storage or document storage for our documentation of our product. We've also used Python as our programming language to write a server that will create some API to make it available for some calls from our front end. Also, we put all processing logic inside that server. So those semantic chunkings and other aspects are put here. But we've leveraged SAP delivered SDKs. And SDKs are kind of a components inside software development process that contain some functions that we can use to speed up some actions. For example, we use this SAP delivered software development kits to have access to a vector engine inside HANA Cloud. So thanks to it, we are able to establish communication between our server and our engine with just a few lines of code. So it is very helpful, and it is also available in other programming languages by SAP. So here's interesting part, because as you see, Python is absolutely not SAP related, but inside BTP, SAP is opening to a new widely available technologies. So not only ABAP is supported here or some Fiori application like UI5 and other, but also many other technologies that maybe are more suited for for solving our solutions. And they are also supported by SAP because, as you see, these SDK are from SAP. And here, for those who maybe already have played a bit with HANA Cloud Vector Engine, we've used the cosine similarity function to compare those vectors, and this function works the best from our perspective. And also the most important part, because the engine, like AI engine that made us available, allow us to create that application, is generative AI hub with our AI core models. So we can see we've used foundation models, one model for creating embeddings and one model for natural language processing, so large language model. And those models are not built by us from scratch. They are just deployed by us. So here you can remember this one option that I've showed you in machine learning operation. We've deployed these models here and used pre-trained delivered models. So that was very fast and very convenient way to build it. And as you can see, it was also quite effective. So not always we have to create our own solution from start to an end. We can sometimes use something what was already delivered for us thanks to SAP. And now let's go into the last part. So a bit about cost of such an application, or some initial cost of investment to start playing with AI. I need to say that it was really hard to estimate, and it's only estimation, so don't treat it as a final pricing on something like this. So we have to use some SAP website, which is called Discovery Center. This website is really helpful because it contains a lot of information about almost any BTP related service or instance or other technology inside BTP. We can just type in this in the search bar and look at the services. If we type in AI, we can see that we have 60 services related somehow to AI according to SAP. So that's quite a lot. We have also some architecture and so on. But also, when we choose particular service, we can look at the pricing. And about the pricing, we've estimated that the initial cost would be at least about 1,000 euro per month. And they are the biggest part in that cost is AI Launchpad and AI Core. And this is because, unfortunately, not like any other BTP services, which have free tier version, this free tier version allows us to do almost everything, to try it out. Unfortunately, in AI Launchpad and AI Core, we need to have paid version to be able to fully use generative AI hub, to have access to our pre-trained, ready-to-use models. And this generates the biggest amount of our costs. And I think this is the only part here that need to be considered as a major part, because it's not working very well with these free tier options. And I would not recommend you in these two particular services to test it with free tier options, because if you do so, then you would probably have conclusion that, oh, it's really not that nice. It's not working really well. So in these two, AI Launchpad and AI Core, we need to have standard and extended version to leverage AI models and generative AI hub with AI Foundation. But one more thing about the cost, maybe not directly, but here is a moment to remember about our 3 R's. So relevant, reliable, and responsible, because we can sum it up as basically governance and legal costs related to AI aspects. And we don't need to add these costs to our financial strategy. Because as I said earlier, all of the governance aspects are taken care by SAP. So if we are keeping our solutions inside SAP ecosystem, we don't need to even know what these technologies, these models are from, where they are from. As an example, we can, for example, create our Microsoft Azure hosted account with Amazon S3 data storage and OpenAI models there. And we don't need to even know that we are using some external vendors technologies, because SAP is taking care of all contracts, of all legal aspects, of all licenses, and so on. And also, important part here is maybe not directly about costs, but about this restriction to legal aspects and so on, is that we can choose what region our solution will be hosted, well, in what region they will be hosted. So what data center will be used. If we have some restriction, for example, to keep our data inside European Union, for example, then we can choose our sub-account inside BTP that is running on some data in some data center that is hosted inside European Union area. And then even if we are using some external partners model, SAP ensures us that our data will not be anyhow redirected outside this region. Okay, and now question and answers. So I will just switch to the question tab. So maybe I will stop sharing my screen and try to try to answer the question if there are any. Okay, so there is one question. This cost is per user? No, these are general costs. So these 1,000 euro per month are costs related with AI services or instances. Creating a user on BTP is free. Basically, creating also a BTP is kind of a free, or you have to pay only if you want to use some services there. And you can also choose the payment model. So you can choose if you want to have a subscription model or pay as you go, where you are just paying for the consumption that you will use. So users are not included in that pricing. So we have the last section. Okay, I see that you're, Octavia, already sharing the screen. So as a takeaways, we pointed out three most important aspects from our perspective for you to remember, and just to remember and to be aware that BTP is playing a bigger and bigger role into SAP Cloud solutions. Then this 3R, so that means that all governance aspects are taken care by SAP, of course, if you trust SAP, and more for like you to interpret that about AI. It's just about a solution, and you can try to think a bit for a while and draw your own conclusion based on this slide's takeaway. So thank you very much. That's all from my side.
Right, Wojtek, thank you very much for your presentation. Thank you, dear participants. You can have a look into the chat window. I sent you the link to our upcoming webinars. You are invited to register. This webinar was recorded and it will be available on our website and on our YouTube channel. Afterwards, there will be displayed one more survey. You are invited to complete it. Thank you very much. This is all for today, and see you next time.